Okay, we're going to continue now with more topics from data and statistics in Chapter 3. Last time we took a look at the distinction between discrete and continuous data and different ways to create tables of information, including frequency tables. In this section here, we're going to be taking a look at some calculations and observations that we make about the data. Now, there's three ways that we classify what we call a central tendency. Central tendency just means some sort of trying to come up with a representative number for a group of numbers. And depending on the style of data that you're given, sometimes different, representative numbers make more sense than others. And so the three big ones that we use are called mode, medium, and mean. Now, in the last lesson, we already took a look at the idea of mode and to some extent mean. I'll just go through. The mode is the most frequently occurring number. Sometimes there's some number that just happens a lot in a data set, and so that might be the more common representative or more sensible way to think of a representative number of the group. The median is when you arrange the data from smallest to biggest, or the other way around, and you identify who's in the middle. Now, if there is no middle, for example, there's an even number of data points, we'll deal with that soon. But basically, we're trying to figure out what's sitting at that fulcrum in the middle where half the data is on one side and half the data is on the other. And of course, for that to make any sense, you're going to have to organize the data from smallest to largest or reverse. And finally, the one that you probably know best is the mean. I think a lot of you probably in the past have just referred to it as the average, not realizing that all three of these different concepts on this screen are all different types of averages. We now, as you get older, make a distinction and call it the mean. And this is the only one that requires arithmetic. You have to add up all the numbers and divide by the number of numbers in the set, or the number of data points in the set. All right, let's move on now. More GDC work coming up here. The history test was given to 14 students, and their grades were given there. We're going to find the mean, median, and mode. And then there's a follow-up analysis question. The 15th student came and took the test, which caused the mean to adjust to 66.2. So what must that grade have been? Okay, start off kind of basic. We're going to go back to our GDC and open up a spreadsheet. We're going to list down all the scores. And I just gave it, you have to give it a title, scores. You can, and I've seen people successfully just call it X and Y and Z and stuff, but that puts the onus on you to remember what these things were assigned. I prefer to write a little quick word just in case there's going to be multiple columns, and there will be soon. You can remember which one is which. Now, again, just do a quick check. The question says there's 14 students. Notice that the final entry here is the 14th score. So that gives me pretty good confidence that I'm okay. Okay, what are we going to do with this information? So again, open up a brand new screen, which is a calculator screen, Control plus Page, and the menu button, Statistics, Stats Calculations, and then at the very top of that next screen, it says One Variable Statistics. You access that, and it provides the following information for you. Notice here the X bar, like last time. That means the mean of the set. Add them all up and divide by the number of test takers is 66. That's what they ask. It says now a 15th student is going to come and cause the mean to adjust to 66.2. So they're going to clearly have done better. I would work this out here. Now take a look at what I'm pointing at right here. This is called, remember the sigma? We did sigma earlier in the course. It meant adding up. You take the sum of, and if you take the sum of all the x's, it says it's 924. That means all of the test scores that were reported to us, all 14, they added up to 924. And in the execution of finding the mean, we divide by how many numbers there are, and there are 14. So 924 divided by 14 was 66. You don't have to perform 924 divided by 14 to get 66, but you could have. So if I want to go and figure out how the 15th student caused the mean to go to 66.2, let's think of it this way. We would add up all the scores from the first to the 15th student, but I only know what the first 14 got. What I don't know is what the 15th student got. And if I were to take the sum of those 15, had I known them, divided it by 15, it would yield the answer 66.2. So what I'm going to do is I'm going to write that idea down. I took the sum of the 14 scores as reported on my GDC was 924. And if I add the 15th score to it and divide that sum by 15, it'll cause my answer to be 66.2. Now that's just an equation which can be solved, but if it's a variable in an inconvenient location, grab your end solve and you can see that this student must have scored 69 points on that test because 924 and 69, whatever that is, divided by 15 does divide out to 66.2. Mindy has some candies. She's going to count up how many are in the bag. Okay, so she's got she's got 23 candies in 2 of the bags, 24 candies in 3 of the bags, 25 candies in 9 of the bags, etc., etc. Before we get going on this, I want to point out that just because there's 5 rows to this table doesn't mean there's only 5 bags of candy. There's many more than that. And I think there's 20 if I'm looking at it properly, because something happened twice, something else happened 3 times, something else happened 9 times, something else happened 5 times, and there was something that happened once. So these numbers here all add up to 20, and that is how many there were, because you got to imagine if you were to list out all the data in long form, you'd have 2 23s, 3 24s, 9 25s, etc. This table, this so-called frequency table, allows us to create a quick and useful summary of what's going on. But you mustn't overlook that there's more to it than just the numbers that you see in the chart on their own. Okay, let's find the mean number of candies in the bag. Now, do I have to go and add up 23, 23, 24, 24, 24, and then 9 25s? No. Our calculator is really good at this. What we're going to do is we're going to go back and make a new spreadsheet here. And I'm going to list all of the scenarios that happened to this person, Mindy, and it was 23, 24, 25, 26, and 27. And I'm going to create a new column beside it, which is a frequency column. Now, you'll recall that not long ago I said you're going to have multiple columns sometimes, so you want to choose the titles carefully. If you don't have some care with how you choose them, you can get yourself pretty lost pretty quickly. You go to a different screen, you've completely already forgotten how you, I mean, I suppose you could write it down somewhere, but seems easier to me just to write down a word that conjures up the memory of what you put there. So I put pieces down here, candy down here, whatever you want down. And then frequency goes beside it. Do a quick check. That looks all good. Now, this continues to be one variable statistics, but you'll see when we get to the prompt screen or the dialog box, it says, where is the list of the different candies numbers? And I called it the column pieces, but now they've given you the option for a frequency list. So they're asking, do you want these numbers 23, 24, 25, 26, 27 to have their own respective frequencies and not just one of each like they had been in previous questions? And we do. So we're going to choose the frequency list to be noted as the column title FREQ, short for frequency. And when it performs the calculations, you'll notice that it automatically does the adjusting for you. Notice it says there are 20 cases overall, and those numbers all add up to 500. And we think, well, what adds up to 500 here? Well, 2 23s, 3 24s, 9 25s, 5 26s, and a 27 adds up to 500. And so if you divide the 500 by 20, you get the mean here, X bar. The mean is 25. Now that's not just because it's in the middle. It's because arithmetically it is the middle, the mean. Add them all up and divide by the number of cases. So here we go, another example here. In each case, interpret the meaning of the values calculated. Discuss why extreme values or extreme mode affect the mean more than the median. All right, let's see. The number of ice cream sold over a 13-week period is as follows, and there's a bunch of numbers. Write down the mode and use technology to find the mean and median of this set. 2 dice are thrown 100 times and your total score is recorded in the table. Of course, 2 dice thrown like a Monopoly game. The scores can only go from 2 to 12. And you can see that there's a lot more in the middle, like the 7s. And you can give them a try and ask questions of me if you have any. Oh, actually, no, let's go ahead and do this. I go ahead and I put down all the ice cream sold in the 13-week period. And you can see that the final number in my chart is 13. I assume I've typed them out correctly. This is single variable statistics, no frequency table. And you can see that the average, or the mean, I should say, is 171.3. The number of them is 13. And you can see down below there, the last full word that you can see on this summary is the median. Don't worry about all the other stuff. There's a lot of time, and I'm going to explore all these with you when they're needed. But for now, the median score was 158. And that means if you were to organize this data from smallest to largest, 158 would be in the middle of the 13. 2 dice are thrown 100 times. Here we go. Now you'll notice again, we've got the scores going from 2 to 12. So that means this final score is actually 11, right? Because the score of 1 is not possible. So 2 to 12 inclusively, there's 11 different potential roll totals. And I wrote the frequencies beside them. So this is going to take a frequency table now to help me. My GDC can do this. And again, you can see that the 100 is there. That means we probably put all of the data in correctly. And the average score was 48.2. Median was 7. That's the middle score. The median, that's all we wanted for this set. Okay, here we are. We're on 3B now. A couple more questions to do. Not very much here. This is more about calculator exploration, making sure that you're comfortable with putting data in, giving it a name, and to work out some basic things from the one variable summary. You can see here's your questions. There's exercise A before we finish that one, and exercise B, just a couple questions to do. And if you look ahead, you can see it is quite a small chapter. So let's make sure these are the fundamental principles of statistics. If we get these understood well, topics down the road won't be as difficult. Okay, let's get to work.